Thanks to the host for the introduction, and thank you everyone for attending this section. I appreciate your time here. And this is actually my first time in Taiwan, and I'm really glad to attend this session here, introducing the TI product, the revolutions that we have here, focusing on the high voltage product for the future generations of power. Again, our goal is to improve the density and the efficiency for the future generations of power and the data center power supplies here. So with that, I would like to open up my speech here and talk about what are the revolutions that we have at TI, focusing on these new areas here. So to start with here, if you look at the power generations that we see on the market here, right, if you look at the data centers, either traditional ones or cryptocurrencies, or even for the AI data centers here, I think in 2022, we're seeing around 460 terawatt hours of power that consumed in the world here, according to the IEA study here, right? And again, this is almost like 2% of the overall power that you will probably see in the world here. And this is part of the reason why we want to invest in this area, because this is talking about the power generation, the power delivery, and to the end, the CPU, GPUs that you see here, right? So this is definitely a lot of power conversions here, which means a lot of opportunity for the high voltage product and power conversion business here, right? And what is more interesting, right, if you look at the trend here from 2022 to 2026, right, that's where you actually see more power deliveries happening in this area in data center, right? If you talk about the range predictions here, we're talking about, almost like, 70% increases here on average here, right? And there are several fun facts that I learned, when I looked through this graphs here, right? The first thing that I learned is like, the increase, right, from 460 to 800, that's almost like at least the whole electricity generation, probably a whole Sweden, right? So that's a little bit shocking to me, when I look at the number and how I correspond that to a daily life that you will probably see, right? And if you're talking about the top here, that's probably corresponding to the overall generation of Germany, right, that you will see in the annual basis here, right? So this is roughly to give a feeling like how much power we're talking about here, and this is exactly where we do see opportunities where the power converted, if you make it more efficient, the power saving, if you can make it more higher density, right? All this is actually going to beneficial to the overall ecosystem to make it greener, right? So I think this is why we're actually in this business, and this is a lot of potential that we see here. But again, right, if you look deeper into the details of the different data centers, right, you have the traditional data centers, right, you have all the different ones for the cryptocurrencies and also the AI data centers here, right? And this is another detail that when I look at the chart here, first of all, I'm definitely surprised and to see that the AI data center is only a small portion here, right? I know everybody's talking about that, and when I look at the portion here, it's actually much smaller than I thought here, right? That's why I look at the data further, and I do realize that the prediction may not be able to catch everything here. Same thing, right? When we see NVIDIA, even when they are predicting the AI data center, they keep changing things here, right? So this tells us where that great potential can be, right? If you're talking about from here to here, this can be another great potential that you see in 2026. I mean, specifically, we're talking NVIDIA, they're shipping about 100K, right, ASIC last year, and they definitely project more, that almost 10 times that you would expect in the next 3 to 4 years, right? So this is definitely corresponding to a lot of power consumption from the data center point of view, right? And that's why we want to look at what's the trend in the data center and how TI deal with that market, right? I think that's the key thing we need to look into. So if you look at a data center, I think the first thing is where the power is generated, right? So you're talking about the power generation from the whole factory generating the electricity, and that's definitely getting more involved in the renewable energy into the system as well, right? And that's what we're talking about, the wind energy, the solar energy, where you will have to utilize all the power semiconductors and the power conversions to do that conversion system, right? So this is definitely one area that we see the opportunities here where TI can play a role, right? And second thing, even if you focus on the data center itself, if you look at the power conversion itself, you definitely need a higher efficiency here, right? Because if you look at data center, you're talking about 40% of them is consumed by the power itself. And another 40% is actually by the cooling, right? So if you can make the system more efficient, you can reduce all the cooling energy needed, right, for the data center power supply, which is almost 40%, right? That's an amazing number, 40% of the whole system. The consumption is by the cooling, right? So if you can make the system more efficient, right, you can essentially reduce the cooling cost, right, and you can actually, greatly reduce your home consumption as well. Right? That's another great benefit that I do see, like, with the high power product. If you make it more efficient, that is definitely needed here. And definitely, if you're talking about the government regulation and everything, this is another degree that people are definitely shooting for, improving the density and efficiency as well in the data center. The last piece I see, again, density. I think this is another interesting point. If I talk with the customers here on each of the PSU, each of the data center, each of the rack level design, I think everybody is talking about every 2 years the power is double, right? Every 2 years it's going to be double and double, right? So we're talking about 1 kilowatt, 3 kilowatt, 8 kilowatt, even 10 kilowatt, or even 22 kilowatt, right? In the future data center power supplies here. What does that mean, right? That means, one thing you can do, of course, you can build more, right, spaces here, more buildings here to build a data center, right? But what people really want is like, how we can improve the density here. So even the same spaces here, how I can put more power, right? That is always what people are looking to. So that means your density of your power supply, it has to be increased here, right? And that is where, again, the high power product from TI I'm going to use about, wide bandgap devices, the GaN nitride devices, those are exactly the devices going to be fitting for these applications to improve the density, right? So I think this is where it opens up a lot of opportunity for data center, and that's why TI is investing its technology here. And with that, I'm actually introduce more details about data center architecture and introduce about how TI is investing here as well. So if you look at data center, right, you have the rack power, server PSUs here, and this is talking about, if you're talking about the modular, MCRPS standards here, right, you're talking about the existing like 96.5 efficiency that you need to meet here, right, and also the density is keeping, decreasing here. The size is, the width is decreasing from 73 millimeter to 60 millimeter, and that is, definite. First of all, high efficiency requirement, but still they reduce the space here, right? So this is definitely a trend that we do see here. And if you look at the cloud business here, this is also talking about even higher efficiency, like 97.5, or even beyond 97.5, like 98% efficiency here. And this is also talking about the power is double, every 2 years that we have seen here in the future PSU designs here, right? So this is another opportunity that you do see where the high efficiency and high density is needed here. The last pieces I see is in the battery backup unit, right? This is an area that you actually need. Some other power conversions, not higher voltage like 350 volt, but more like a 40 volt to like 100 volt power conversions in between the batteries, and this power supply, where again TI have a lot of product to attack here. Again, the need of the high density is also true there because it's interfacing between the battery and the power supply, and that's where you actually need to have a higher frequency operation on those power supplies, so you can again push to higher power from the BB unit here, so you can squeeze in all your devices and inductor passive components into that same space here, right? So again, all this is leading to a need of a technology, right? That higher efficiency, higher density. And what is that, right? And I think this is where I'm going to introduce about what TI have here, right? And one of the products is definitely the gallium nitride devices here. I know this has been a key topic in this session here, talking about gallium nitride silicon carbide devices here. At TI, we are investing on the gallium nitride devices actually back in 2010. This is where we study all the, in terms of the process, everything, because TI is always like IDM approaches here. This is where we are, also doing the manufacturing, also doing the device design within house here. So we actually started that in 2010 here, and this is where, at the beginning, we actually really focus on a lot of industrial power supply and also the automotive application, and plus some of the solar renewable energy here. And that's where when we pick the technology here, we actually pay a lot of attention to the reliability and qualification of the devices for those mission critical applications here, right? So this is talking about we actually spend quite a bit of effort here, right? Establishing a lab to test the reliability of GaN devices, and also starting the GEC committee here, right, on GaN devices here. Because what is applied in silicon may not be able to apply the same thing to GaN if you really want to make it reliable in the real application here, right? So this is why, how we invest in GaN here. We focus on industrial, automotive, and solar energy applications here. So this is along the path here. It takes us a while, honestly, to get started and make a product here. But once we relaunch it, good things like we're actually shooting and we're indeed shipping that in the telecom power supplies here. And this has been since 2018. We have been shipping that in the power supply units here, and now extending to the server applications as well. But definitely along the path here, is where we will continue our reliability testing. You will see that we already passed 40 million hours of testing based on our devices in the lab here. I think even when I'm speaking here, I'm pretty sure the lab is still operating that, still testing the devices reliability here, right? So I think this is critical, because if we are talking about having GaN, right, having the new generation devices applied in the industry, right, a proven reliability is the key here. I think that's what we spend definitely a lot of effort. And the other piece we did spend a lot of effort is how we can further improve the density, right? And this is where we look at different means of doing power devices here. And this is where we believe the integration, the driver of the devices, and having more features is actually needed. Right? This is not just talking about integrating driver to maximize the switching performance of devices. And this is also talking about improving the robustness by having internal integrated protection level, plus having more smart features that you have the sensing that can facilitate your control, right? And this is where we see the opportunity of GaN, right? Specifically, we talk about, yes, we want GaN, we want to maximize that with the integration to maximize efficiency, and that helps us to improve the density as well, right? But we also want to make sure that the protection level is there to making sure it is reliable and robust in the system. Plus, we do a lot of internal qualification just to make sure that the GaN device is suitable for those applications here, right? So this is indeed what we're doing here. Plus, in the future, we do see more integration that are going to bring new, technology in terms of new topology and in terms of new control. That is definitely something that we are devoted ourselves to bring the innovations to the industry. With that, I'm actually going to give you one example, which is more focused on the, I would say, the PSU side, on the PFC. Right? This is talking about how the high voltage GaN devices can benefit in the PFC here. Right? So if you look at the most of the silicon designs here, the AC switch is kind of one common topology where you actually have two active and 4 passive components here. Right? And you can also have the active bridge here if you want to further improve the efficiency here. But this is adding a little bit cost here because you're replacing the diode with more active devices here, which is adding cost here. And still, this is with silicon, the best tool that you can do here to have different options. Talking about different efficiency target here. But with GaN and silicon carbide here, you can definitely move to the totem pole topology very easily because with GaN, you eliminate all the reverse current losses here, so you can easily go and replace those active bridges with this totem pole topology and use the GaN devices in the fast lag here because you can remove the reverse current losses and you can move to a higher switching frequency and you can maintain a pretty high efficiency here. But again, I know people care about cost here, right? And this is where we did a lot of analysis to prove that if you replace the low frequency lag with the diode, actually the cost is pretty low, right? And even if you replace that with a MOSFET here, again, which is not a fast switching MOSFET, actually the cost is just a medium added here. But the benefit that you're adding here is actually you see a great improvement on efficiency, and that is definitely needed. And also you can push to even higher frequency, which is talking about the overall system density improvement. Again, the density is not just talk about the totem pole. The density is also talking about even with totem pole, you can have the more options here to explore and to go to the CRM and TCM different control mode here to push to even higher frequency. Right? In our reference designs, we are talking about even 800 kilohertz of totem pole operations here that can help you to further improve the efficiency and density here. Right? So this is definitely where we do see GaN on the high voltage side on the PFC as an enable energy. as an enable technology here to to I would say, revolutionizing this area for higher efficiency and higher density here. But again, if you look at the overall path, right, I mean, we briefly talk about the PFC stages here, focus on here, where TI have the GaN devices and also the controller here available. But we're also talking about if you have the conversion from the PFC AC to the DC, and then DC to 48 volt here, you also have the E-fuse. This is also TI have the product here to be used in the enterprise applications here to have the hot swap here. And then with 48 volt, you actually need more conversions here, where you're talking about a 48 volt to 12 volt or 48 volt to intermediate bus converter, which is leveraging also the GaN devices and also our UCC and our C2K controllers here, which is also the available technology at TI to make it a higher density and higher efficiency here. And then towards the path here, runs through the intermediate bus, then towards to the GPU or CPU here. That's where you will see the multi-phase buck modules here or point-of-load converters, which TI also provide a pretty complete portfolio here. But overall, that's where you can see our investment from TI on the data center is we want to have a full solution from end to end here, from the AC, from the grid, and tied up to all the CPU, GPU here. And that's where we're dedicated to provide different solutions and technology here to continue to improve the density and the efficiency. But beyond that, right, I mean, the same product, you can definitely see that in a lot of the telecom power supply here, and the battery backup unit, and for other renewable energies like UPS, industrial power supplies, and some of the consumer applications, which you probably see more with the GaN devices as well, right? Again, this is where we're dedicated to work together to make the world greener, and this is where all the product here is released here to make it more efficient here. But to summarize, in terms of the GaN technology, where I'm coming from here, from the GaN product line, this is where, as the market have a higher needs for the higher power, and this is where, we do need to leverage the GaN devices to make it more efficient and to improve the higher density here. And this is where we believe GaN is the right technology to improve and to have a path to higher efficiency and density here. And we continue to do the integration here. And we're doing integration to improve the system robustness, the device's performance, and also to facilitate the system in terms of the control, in terms of all the sensing as well. Right, and at TI, the way that we develop the GaN devices is we leverage all the internal manufacturing, and we are providing our capacity here for the next 10 to 15 years for the GaN to wrap up here. Right? So this is where GaN is a good device, and I'm happy to see more people using this, and definitely this is a good page that you can visit and to look at our technology and products here. And this is a good time I can also conclude here to take any questions. Hopefully all in GaN, but again, if not GaN, I will try my best to answer other questions here. Thank you.
Okay, now we have a Q&A time. Any questions? Yes.
Thanks for your presentation. I think the question is that in this high efficiency, this power application, especially for medium voltage below 100 volts type of application, do you fully embrace the GaN technology, or still keep doing some advanced MOS technology?
Yeah, that is a great question. I know I highlighted a lot of the high voltage GaN devices, but definitely you probably see a lot of GaN devices in the medium voltage, like the 100 volt, 80 volt, 170 volt here. And I do see that as a great potential as well in the data center. Right? For example, if you're talking about the brick module for the IBC intermediate bus converter, right? The way that it's actually pretty adjacent to the ASIC and power here, right? If you really want to put more ASIC on a motherboard, that means you probably need to improve the density of the power supply so you have enough spacings for your ASIC, right? So people are talking about how I can refresh my intermediate bus converters to be smaller, but again, higher density, higher power, right? Even though it's smaller. And that means the conversion stage needs to be more efficient, right? So you can reduce losses, that's how you can make it smaller. And also it has to be pushed into a higher switching frequency in a way that you can reduce the magnetics to make it smaller, right? And this is where I do see the 100 volt GaN as a very fit technology here on the 40 volt side here. So you can push to a higher frequency and leverage GaN technology to make it smaller and more efficient. And this is where I do see that it's happening in IBC work here. And the other example is also talking about the battery backup unit, where you're interfacing from the 40 volt battery as the backup unit here, right? In case your main power lost, you need to have the backup unit to instantaneously having 10 kilowatt, 8 kilowatt from one phase of the BBU units here, right? And this is talking about, hey, this is a power supply, it's also part of your rack here. Again, the goal is like you want the rack to be more filled with your ASIC, right? More with NVIDIA AMD product here. But the way that it can do that is you need to make your power supply smaller. And also you still need a higher power, because when they put more ASIC there, your power in converting the power, it goes up. And this is where the GaN, the 100 volt GaN is also a good fit for that, because this is talking about 40 volt, to maybe 54 volt here, and this is the buck boost, is the right technology for the GaN devices, 100 volt GaN devices, to push to higher efficiency, also pushing to a higher operating frequency to reduce the inductor size here. Again, those are the my personal experiences where GaN is definitely having a lot of good potential, even for the medium voltage GaN in the data center. Yeah. Thank you.
Okay. Yeah, thanks for the nice talk. And I just wonder, for TI, and you guys also doing because GaN reliability is very important. Yeah. So is there any special like wafer level testing or any kind of module testing for improve the reliability?
Yeah, of course. So I think this is talking about different level of testing here in terms of how we qualify the process here. But that's the first thing. This is where, in my presentation, I talk about the GC17 committee. We actually want the founders starting that committee here, because we know this is critical, right? What you test in silicon, the same methodology, if you pass everything, does not mean, you can guarantee GaN is good, because the structure is different, right? You have to test its weaknesses, right? And that's always in our methodology. If you really want to have a good product in the industry being acknowledged, we have to address that, right? So this is why you have to test differently, right? So what we did here is we started the process testing, which is, talking about how we test it, how we validate that. And we also do a lot of application tests here, right? You can see from our web papers, public web papers here, talking about how we test in real application, having hard switching, soft switching, voltage, current overlap, all the stresses here, and how we validate that in real application, right? So I think this is talking about a lot of detailed testing, not just the regular process testing for the silicon, but also testing about a product. Of course, they have a pretty stringent, product level qualification here, but we also want to do more, which is talking about application-based testing, so we can give the, all our customers a good confidence about the GaN reliability. Right? I think this is the 3 steps that we have been doing here, and it's all public information that you can check here, which have probably more details here. But again, we are dedicated to making sure this is a reliable technology that when we launch the product to the industry, I think that's a critical piece.
Thank you.
Yeah.
Yes?
So thank you, Dr. Yang, and thank you for the presentation.
Yep.
And I saw you have already launched TI GaN Gen 2,
yep.
the device, the GaN device in 2020.
Yep.
So would you share that any strategy you're planning for the Gen 3? I believe they will come in soon, right?
I mean, there will always be more to come. I can share with you in this way. We are talking about, if you look at our portfolios that already in the public, you will see the Gen 1, Gen 2 are talking about different package size, different RDSM, because the Gen 2, the whole revolution is talking about a larger package, so you can dissipate more power losses, right, to help people to push more power, right? So, and the Gen 3, if you're talking about what you already see in the public, you probably see the 100 volt GaN devices we already released here, right? This is definitely another generation that we are bringing here, right? But again, I think we'll have a consistent investment in our devices, which means you will be able to see more real-time devices, more diverse, and more voltages, and that's where we're going to continue to invest in here, right? And again, this is not talking about a 1 year, 2 year work that TI is investing in GaN. We have been investing in GaN for 10 years, more than 10 years, since 2010, if you're talking about the technology here. And we will keep doing that for the next 10 to 15 years because you see we are already expanding our capacity here, right? So this is talking about a continuous investment and non-continuous development of product here. Again, I can share what we have seen here, but again, you will see more generations. That's where I can guarantee.
Thank you.
Thank you.
Sorry, one more interesting question is that now we're seeing many products on like the 8-inch GaN wafer.
Yep.
Any plan on the 12-inch?
Yeah, I think this is where you will see all industries moving that. TI is definitely part of the journey here as well. So, yeah. Thank you.